Okay, so far we have learned how to transform a function into its Fourier domain and taking it back from Fourier domain to the time domain. Now I will show you some examples, some sample functions we frequently use in image processing. One of the most important one is box function. This box function has width of w and its amplitude is, let's say, a. It's in time domain. So let's take its Fourier transform. F of mu is equal to integration or infinity of our f of t. This is our f of t. In this case, f of t e to minus j 2 pi mu t dt. Since this function is only has non-zero values in between minus w over 2 to plus w over 2, this integration will change to minus w over 2 to plus w over 2. And then now instead of f of t, we have a e to minus j 2 pi omega t dt. This has turned into integration of a complex exponential, which is well known, and this is equal to a over minus j 2 pi omega times e to minus j pi omega, mu w minus e to j pi mu w. If you expand it to sinus and cosines components, they all cancel. Some of them will cancel each other, and then we will be left with a times w times sinus pi omega w over pi omega w, which is equal to f mu. Now here's mu is our variable and other numbers are constant. So this function should look familiar to you. It's like sinus x over x. Probably you have already found value of this function at 0 in calculus. So this function at 0 is equal to 1. So let's try to plot this function. We know how 1 over x looks like. This is how 1 over x looks like. And sine x over x starts with 1. Then it slowly comes down. Now the rest of it will look like a sinus, but amplitude will be scaled down by 1 over x. That's the negative portion of 1 over x. Also we have symmetric part of it. And it goes on like that. Now this function is called sinc function. Remember what we did here. We took Fourier transform of a box function and then we found a sinc function. This box function is limited in between minus w over 2 to plus w over 2. But its Fourier transform has infinitely long tails. So those tails actually gives us some trouble in image processing.